try this?
Yeah, fine. I'll hold this.
Start? It's there. We'll do that, right?
Yeah, let's do that.
Okay. No, we need two speakers. We'll use that. Hello, everyone. Am I audible at the back? No? How about now? All right. Okay. Thank you very much. I know you guys are missing some amazing action in Audi 2 to be here. We really appreciate it. My name is Jeffrey, and I'm joined by my super smart fellow technical director, Utkarsh. We are from DreamWorks Animation Pipeline, something that we built at India for working on movies. So again, we're from DreamWorks Animation. One of the things that we do is make movies, but at its core, DreamWorks Animation has a beating technical heart, and we represent that. So who in here likes Python? Wait, that's not. I mean, who in here likes movies? All right. So everyone likes movies. Cool. I thought we'll start off with, a movie that we just finished. Well, we're finishing working on. It's called Penguins of Madagascar. It's out in November.
Attention! This is Penguins of Madagascar. But what you don't know is they've been leading a double life as secret agents. Their untold story began as four brothers.
Are you my family?
You don't have a family, and we're all going to die.
What? What's the matter with you, Kowalski?
Grew up to become masters of disguise, espionage, and aerial assault.
Howdy, boys! We're going in hot. No one likes to show off, privates.
Now, when it comes to stopping a madman,
I have the power to destroy you.
you'll have some competition.
What the heck is going on?
Remain calm, penguins. You are now under the protection of the North Wind.
We don't even know who the heck you are.
The North Wind is an elite undercover task force dedicated to helping animals help themselves.
This November,
You got a soggy madman to stop.
I give the orders around here.
You were supposed to handcuff them,
But they don't have hands. They just have flippers.
and I have flippers.
So it's flipping useless.
the world needs saving.
After them! Hi, boys. It's just like Cuba.
Venice, Rio de Janeiro, Dusseldorf. We've arrived in the center of Dublin, Ireland.
We gotta blend in.
Riverdance. Heroes. We don't need these guys. Become legends.
Penguins are our flesh and feathers. If anyone's gonna save us, it's us.
The creators of Madagascar.
He hacked into our system.
Debbie. Dave.
Where's the sound?
Dave, your microphone, it's not
Click
on.
on the button with the picture of the microphone.
Every time a villain calls in, this happens.
Hello? Now we can
So
hear you,
annoying.
but we cannot see you.
Every time.
That's like talking to my parents.
DreamWorks. Penguins of Madagascar.
We need to find intel on Dave's location. Hey, you! Where's Dave? Give us the goods.
So that's a baby squid.
Sorry, laddie.
I hope you like that. Thank you very much. So we have a lot of stuff to get through. So I'll be really quick. So as I mentioned, we're DreamWorks technical directors. We work on animation pipeline. Am I audible at the back? No. How about now? Okay, this is exactly like the trailer. So yeah, we work on animation pipeline. We enable artists to perform these amazing imagery and movie. We come up with workflows for them to make movies, and also we build services to help make movies. So we're going to focus on the third thing today. That's actually what we call as a transfer pipeline. Now, so why was this required? Well, we do a ton of collaboration. Movie making is not a single person job. We have a big crew working on it. So we had to have an efficient system. Why is this required? We'll come to that. But just know that movie making is a highly collaborative process. We have two kinds of data that DreamWorks produces. One is the handcrafted data that artists produce, and the other one is the generated data that procedurally we generate. Now, quick turnaround, well, yeah, quick turnaround is required because we can't do this even a single day while making movies because we have to be on schedule because otherwise the movie never gets released on November 25th. So, and also there's a ton of data going around. There's a huge amount of volume. And this was the very first time something like this was attempted outside of Hollywood. So again, the onus was on us technical directors at Bangalore to come up with a solution that worked across the board on a Hollywood animation movie. So we evaluated a couple of things. We looked at rsync and SCP because, at the end of the day, this is just local and remote site. Can we use rsync and SCP? We quickly realized that, we needed a little more reliability. Sorry about that. Yeah, we quickly between Hollywood and Bangalore. We also looked at some filer level syncs. We use NetApp solutions, so SnapMirror, SnapCache that enables filer level replication between sites. This was a complete black box for us, and it was kind of hard, again, for certain reasons. We also evaluated cloud, and unfortunately, DreamWorks does not like to put its IP on someone else's servers, so this was out of our, we couldn't use that. So we came up with a solution, the 1.0, which was built at 2009 when the studio was established in Bangalore here. It was cron-based, as with any hacky solution would be. We used ticketing system, Jira as the backend. It was a very, very novel idea. It was super unreliable. It was not scalable. We did a couple of TV shots with it, but we quickly realized that we can't do this for movies. And Python was chosen because we wanted quick turnaround. Again, the movie production had to start at a certain point, and we didn't have the expertise nor the time to actually implement a most efficient system. We just had to get something up and running really, really fast. So, well, once we realized that it was not going to work, we started working on version 2.0, which is actually what we're going to talk about today. We started work at 2009. It's handling hundreds of GBs of data every day between Hollywood and Bangalore. We built accountability into the system so that we can actually ask, hey, is this particular thing in US or India? Is this actually here? Can the person start working? All those kind of questions. It had to be super, super reliable because we are going to give the solution we're going to put this on production, and artists and production producers and directors are actually going to use this, and they're not technical at all. So something that would work all the time. So transfer pipeline today, it has some 100,000 lines of code. Again, lines of code is not a good metric, but it's there. It handles 1 to 2 TB of data sometimes when there's a lot of traffic. We use Python 2.7 in the studio. Again, really quick, the service is actually interfaced by automated hooks. So we have a ton of automated stuff that's happening: movie generation, particle simulations, other hair simulations or animated data. All those things are via automatic hooks that talks to the system. We also have artists directly interacting with the system. So we also wanted a system that allowed people to talk. So think REST, JSON APIs, all those kind of fun stuff. And also there needed to be a front end. We use Qt. PyQt actually, to provide some nice little GUIs for people to use inside their application or even outside just on the command line. So we provided all those. This is just I don't know if it's visible at the back. This is last 2 weeks of data that we transferred one day. Sometimes it went up to 100 GB. This is pulled every 15 minutes, I believe. And there's also another graph that shows we do see variation. Actually, it's very interesting. You can actually see when it's night, there isn't a lot of traffic, or towards the evening. So some interesting patterns there. So really quick, the system architecture looks like this. We're going to jump into this a little more deep, and Utkarsh is going to help us do that. We have Bangalore on one side. We have Hollywood. That's Los Angeles, and we also have a studio in San Francisco. So we needed to have a system that worked across the board. So we have a load balancer that represents the circle roughly, and we also have services, twisted services, sitting on it, reading the same file system, NFS mounted file system, that enabled this. We use Redis, and we also have reliability. We also use Oracle as a backend at this point, and that something happens, and Utkarsh is going to help us, walk us through that. Over to you.
Can you guys hear me? Yes? Okay. So we'll head straight into what the technical bits of this entire system are. How many of you guys attended the async talk today morning? It was pretty good. I guess those guys covered mostly Tornado. We'll be looking at, our system is based on Twisted, so we'll be looking at how the daemons, the load balancers, the databases, and the watchdogs are implemented with Twisted. So what is Twisted? Twisted is an evented, asynchronous, non-blocking web framework. With this you can create pretty much anything. You can create a website, you can create an FTP server, you can create something like Dropbox. Pretty much anything network related is possible, and Twisted is the grandmother of all async frameworks out there right now. There are a few new ones coming out, but this was the first one, and the first one to prove that, okay, this is a reliable pattern to follow. We used XML RPC for the communication between daemons. We'll see a bit of examples of that. We have daemons, we have load balancers, watchdogs, and one of the key things is not everything can be made asynchronous. We'll see some examples of that. That's where Twisted gives up and says, okay, no, I cannot do this, you have to use a thread, and we'll see some concrete examples on when that happens. So here's an overview of what one particular code path looks like. So we have a user, a happy user. He says, can you guys see that at the back? What that's written? No? No, okay. So I'll read it out for you guys. What it says is request transfer. So the user said, okay, I want to transfer so-and-so files, so-and-so 1,000 files. What happens is that goes onto a queue. So we have a system which says, okay, at a time only about 20 transfers can happen. So it goes onto a queue. It stays there for a while. It might be 1 minute, 2 minutes, 5 minutes, depending on the load of the system. Once it gets a slot, it runs rsync, SCP, something like that, and actually transfers the file. Once the transfer is done, we no longer need the files here in India. So we archive them, move them to a tape storage or something like that. That again takes us some time. And we ping the other side over the internet that, okay, please start unpacking these particular files. So again, that goes into a queue. We have a limitation of 20 files, 20 transfers being unpacked at a time. And then you run tar_exif. That's the actual command that extracts everything. And again, you archive the tar file and you do some cleanup and you have a happy user. He has his files. So that's the main architecture. So what we'll be looking at is just the left side of the screen. How does that work? We'll be looking at some of the technical details of that queuing, how the events are happening, and things like that. So the reactor pattern. So we're looking at just the left side of this particular screen right now. So the user said transfer file XYZ. So what does this mean? What are the things that need to be done right now? There are 3 steps. You need to create a tar file. The user said, I want to transfer 1,000 files. Make one single tar file out of it. Rsync this tar file. And then ping the other side, okay, please start unpacking this particular thing. So as you can see, this kind of fits perfectly the evented model. Once tar CF finishes, you start rsync. Once rsync finishes, you do step 3. So that's how the evented model of Twisted helps us. And you'll notice this is mostly IO bound. You're creating files, you're syncing them, and you're pinging them across the network. So that fits perfectly with the Twisted model, async IO. Everything is IO, so Twisted was the perfect thing for this particular case. So here's what a bit of Twisted code looks like. So the user said, I want to transfer files. He gives a file list of, let's say, 1,000 files. We build a command. It's pretty straightforward. And then we use the utils module and say, get process value. What that does is it executes the tar command in the background, waits for it until it finishes, and once it finishes, it will run this particular function called self._sync file, which I think is on the next slide. Yeah. So what's happening here is utils or get process value is returning a deferred object. A deferred object was is similar to the future. If you attended the async talk today morning, what a deferred object does is it's a promise that in the future it will have a value. It doesn't have a value right now, but it will in the future. So what getProcessValue does is it returns the exit code for tar. So if it's a 0, then everything's fine, nothing wrong happened. If something bad did happen, it will return an exit code, say 33 or 45. In that case, we can handle, okay, it went out of memory, or the files were unreadable. So we can handle those kinds of cases with Twisted. And once this finishes, you do sync file. You're essentially just checking if the process value is not equal to 0, then raise an exception. Highly simplified version. Otherwise, run the rsync command, and we do the same thing again, get process value and ping the other side to unpack everything. Does that make sense? If you guys have questions, please let me know. Okay. So once you start working with Twisted, you'll figure out not everything can be made asynchronous. So one of the examples, since we are a file system kind of a service, we figured out these are two things that cannot be made asynchronous. We are listing directories with lakhs of files. That is bound to take time. But unfortunately, there is no method in Twisted which allows you to do that. Similarly, fetching the end time of files, that's just not possible. You want to find out when was everything in this directory modified. It's going to take a while. Why is that the case? Because it's asynchronous I/O. Everything that's based on file descriptors can be made asynchronous. Unfortunately, these two things are not based on file descriptors. So the common saying that everything in Unix is a file is kind of usually true, but these particular cases it fails. So for these cases, you need to fall back to threads, and Twisted gives you a really cool interface to do threading. What happens in Twisted is there's a thread pool of, I think the default is some 10 threads. You can change that, and all you need to do is run threads.defer to thread, and what it'll do is pick one thread from the thread pool and start running do list dir in that particular thread. Once that task finishes, it will call the callback on T as mentioned. If there's an airbag, you do add airbag. There are also a few interesting functions. There's a call from thread, call in thread, that let you communicate between different threads as well. So I found those to be really useful. So until now, everything was just Twisted. So I was assuming you're starting to make a new service. That's when you'll use all of this code. But as you get used to this particular paradigm of coding, you'll figure out, okay, every single problem I have is asynchronous, and maybe I can use Twisted for it. And that's when you realize, okay, I have this script, it does a certain things, and then goes to the internet, fetches some pages, maybe it's Scrappy or something like that, and then it figures out some more algorithms on those pages. So you'll figure out, okay, I was doing fetch page 1, fetch page 2, fetch page 3, fetch page 4. Instead of that, I can do fetch page 1, 2, 3, 4, and then as and when the pages come, I'll process them. So Twisted lets you do that really easily. It plugs in to your existing systems pretty easily. But there are a few rules you should abide by. The first one is really handle every error, put airbags. It might not sound really big, but if you have a synchronous script and you're just trying to put a reactor in between, you'll figure out if you don't handle an error, your script might never exit because the reactor is just an infinite loop. So yeah, just make sure you handle every single error that might happen. For example, if you're connecting to the Google auth API and for some reason the connection drops, you need to figure out, okay, the connection dropped, I need to stop the reactor, or I need to start the reactor again now. And that brings us to the second point. Make sure you stop the reactor properly, because it can be tricky to stop the reactor properly. So in the previous slide, we created a thread here. So if you're creating threads, there's one main thread and some additional bunch of threads running. So you need to make sure all those additional threads also exit. If you don't do that, you'll figure out that, okay, your script ran fine, nothing bad happened, but after a couple of hours, a couple of days, depending on how much traffic you're getting, you'll figure out your processes aren't exiting. And why is that? Because your threads did not exit on time. So just make sure you kill all, somehow, not kill, but make sure all the threads exit properly, and then stop the reactor. Oh, and if you have a cute GUI, just put this module into your code, and the Qt event loop and the reactor will start working together perfectly in perfect synergy. And I actually found that using thread.call from thread and call in thread are a better and more flexible way than signals and slots in Qt. So you might want to try out this particular module. Any questions till now? Okay. Can you guys see this at the back? Okay. So that is how you run a twisted application. You define an application. An application consists of different services. One might be an HTTP service, one might be FTP. So you say that's your main application file, that's where the log goes, and that's where the PID file is. But as your traffic increases, you'll figure out, okay, there are some limitations. You'll start seeing file descriptors running out. And that is because just running that command creates a reactor that uses the select system call. So what you need is an epoll system call. And it's as simple as doing that. And now you can literally scale to 10,000 connections if your machine allows, and it'll be perfect. It'll just work out of the box. So these are the main system calls used by a lot of the async frameworks. Select, poll, epoll, KQ. Select is the original one. It's found everywhere. It runs on every single device. It runs on a mobile phone. It runs on embedded devices. Similarly, there's poll. So select has this limitation of 1024 file descriptors. So you cannot have more than those many connections. Poll doesn't have this particular limitation. Epoll is a slightly more optimized version of this, and KQ is the best one, but unfortunately it's not available on Linux. It's I think not just file descriptors, it's everything. Signals, semaphores, processes, everything can be multiplexed by KQ. So if you're using Twisted, you'll figure out that as your traffic increases, the number of errors that happen just because it's on a network increases quite a bit. Interestingly, the one at the top is Twisted, and being at the top is not something that's good. It's the number of errors happening. So what you need to be ready for is timing out these particular connections. So what's going to happen is your client will think, okay, fine, I've connected to my service, but I have not received any responses yet. And it'll keep waiting. And it'll keep waiting. Nothing will happen. So you need to time out that particular function. And I found that this particular snippet does the job every single time. You might try timeouts provided by the library itself, but that sometimes hasn't worked. So that's a system level thing, and that always works. So you might want to include that if you're making a highly scalable system. So load balancing, we are using this particular project called TX Load Balancer. There have been no updates to this project since I think 2008. But we've been maintaining this in-house. We've added quite a bit of things, consistent hashing. We've added a lot of different ports to this. So yeah, we're maintaining this in-house, and it works pretty good. So how do we contact these services. So we've made services with Twisted until now. I mentioned we used XML RPC, and the reason we use XML RPC was because contacting the services is super simple now. So this is some code from a client, for example. What we're doing is we're connecting to example.com and saying just transfer files, which is the same function we looked at a while back. So it looks like you're just running a method on the other side, and you don't have to do some funky URL or something like that. And yeah, the main thing is it's super simple, and you can add new things to it really simply. We're also using the Oracle database and SQL. Interestingly, Twisted comes with a module that just plugs right into Oracle, and all we need to do is just run the query, and it will pick a connection from a connection pool and do stuff. So we have like 3-4 connections open to the database all the time, and you can just run query whenever you want to. So how we've been developing and deploying, I'll just quickly run through this. We have Git, we build with sconce, and we have rolling deploys. We have a bunch of transfer machines. We test it out on 1, test it out on 2, test it out on 3, and the cycle continues. So message queues. So this is something interesting we did pretty recently. We started using Redis for queues. So remember the queues I told you about, the transfer queue, the unpack queue. So that's implemented with Redis. So the client goes and says, I want to unpack a ticket XYZ. So what does the server do? It simply adds it to one particular key, which is, again, that's quite technical, but yeah, it adds it to a set, and the set doesn't have duplicates, so that's pretty nice for us. And we have a looping call on the servers. What a looping call is, it just runs one particular function every 10 seconds. So in this particular case, it will run scan queues every 10 seconds. And what does scan queue do? It does redis.spop. If it returns none, we do nothing. If it does something, then we add it to the processing queue and then do the unpack business. So that's the part where we use Redis for queues. One more place we use Redis is for analytics. So we wrote this module in Python, which generates analytics in 15-minute chunks. So you'll see that the key, are you guys familiar with Redis? No? Okay, so let me back up a little bit. So Redis is an in-memory database. You say, you can say one value equals a certain value. So tp2.daemon gld unpack is equal to that particular list. So that's all Redis is. You store key value pairs. So that fits perfectly for analytics. So what we are saying here is tp2.daemon.ttp.events.whatever, and then a timestamp is equal to some number. So that timestamp is actually the Unix timestamp, and we do this for every 15 minutes. Interestingly, we have about 20,000 keys being generated every day, and we found that it's blazingly fast, Redis. In fact, it's so fast that people often recommend that you should not have callbacks in Twisted, because if you add callbacks, that's adding more latency to your code than just running it in synchronously. So that was analytics. Some of the lessons we learned with this project: simplicity. So again, so let's go back a little bit. Jeffrey had mentioned that this service is going to be used by people who are not technical at all. They are artists, they are directors, they are producers. So it needs to be dead simple. This is something that a lot of the big companies just say it for the namesake. For example, some companies actually do it. For example, Dropbox, dead simple file sharing. Similarly, we have to make it dead simple and trustworthy at the same time. So doing that takes effort, a lot of effort, and it mostly boils down to talking to your customer and asking them, okay, is this working for you? What can I do better for you guys? The next one is testing. So before this particular project, I was a fan of unit testing. After this, I changed my mind. The reason is unit testing just makes your code look really ugly, and you're doing it for what? For testing if your function X works. Is that relevant? I really don't think so. Unless you're working in a team that's 100 developers and you have 100 people committing code on the same time, I think unit testing is not really useful. Instead, what you should go for is functional testing. Are files being transferred? What happens if I unpack a file? Those are the kind of questions pretty much everyone, me the developer, the artist, want to figure out. They want to know, is the system working or not? That's what they want to know. They don't want to know, okay, yeah, fine, your 1,556 tests are working fine. And this is the biggest one, expect failure, especially on the network. So there can be, since we are a file mover kind of a thing, there are a lot of things that can go wrong. The disk could be disconnected. The disk could go out of space. The network might be disconnected. The machine might go down. And this is happening across dozens of machines. So expect failure at every single point in your code. Go out of the way and figure out, okay, this might go wrong, this might go wrong. And once you think you've figured out everything, go show it to your colleagues, and they do it and do something that you wouldn't have thought of. So yeah, that's about it. Thank you. Any questions? Yeah.
By the way, the slides should be up there in case you want to browse right now.
I can see that you are using XML RPC for the calls. It will be a lot more simpler if you are using REST-based, right?
Sorry, what?
SOAP might be a little heavyweight here, but you could be using REST-based calls, right? It will be a lot simpler, right?
True, but we kind of went with what Twisted gave us initially, which was XML RPC. I think that, again, there's a ton of stuff that has happened. The development started in 2009. We were using XML RPC, but you're right. If I were to start a project today, I wouldn't do XML. I would much rather go for JSON, REST-based, communication. But what we have today is an XML architecture, though. But yeah, you're right. If I were to make a call right now, I would probably go with REST-based system. Yes. Any questions? Even if it's related to movies, it's all right. Yes, right there.
Okay, you just mentioned about the reactor event.
Uh-huh.
Now, I know there's another model like a proactor event. Is there any difference between those two models?
What is the other one?
Proactor event.
Proactor event. No, we're not. The question was, the gentleman knows about proactor event. How is that different from reactor? We are not aware of.
Not familiar with that.
Yeah, we're not aware of proactor event. Sorry. Oh, the question is which other areas do we use Python? So I should actually mention this, but DreamWorks is very, very heavy on Python. All our pipelines made in Python. So yeah, I mean, a movie animation pipeline where actually data moves between departments. The glue is Python. And now why Python? I mean, it's easy to find talent. It's easy to get used to it. If you know C or Java, it's actually it's as easy as getting, you just have to learn the syntax, and it's runnable pseudocode, right? So we use Python extensively. Of course, our high-performance systems are written in much more low-level, not low-level, much more performant languages like C++ or Java. But most of a pipeline, if not all, is actually in Python. And this actually is one piece in the pipeline. When I say one piece, what are the different things that enable us to make movie? Transfer pipeline is one of them. We have a lot of other things and all of them are actually in Python. Yeah, right here. Yeah. So the question is, we use scons. You want to take?
We use scons for pretty much everything. Right now, even for, if I'm not wrong, even for our performance code, we use scons for everything. It's just that we find it a lot easier to specify build rules in scons, and yeah, it runs just pretty amazingly. That's what I think.
So yeah, we used to use makefiles, and we made a big switch over to scons, I think maybe a couple of years back, and almost all our tools are using scons at the back end to build. Yeah. Any other questions? Did I see a hand there? No. Is there a question there? Shout it out if you have a question.
I have heard that compressing movie files is not so effective as compressing text files or something. So how do you achieve, what do you achieve by compressing with tar?
Okay. Yeah. So the question is, compressing movie files probably isn't that efficient as compressing text files. So when we say movie files, remember those are actually the data that makes up the final movie. So remember, there's a ton of different types of files available. We found that some of them are highly compressible, some of them are not. To give you a little more detail, the tar command that you saw was our way of isolating files. These files continuously change. So we had to isolate it somewhere, and tar is quick. We don't really care about the compression that much at that point. We just wanted it to be isolated. Did you have something?
And tar doesn't have, we don't compress files by default. A lot of the data we do move is pictures, images, that's already compressed, movies, that's already compressed. We move a few text files, that's not compressed and can take advantage of this. So we have options which let you do bzip compression. By default, we do just tar, and tar is nothing but just concat all the files and just transfers it over. If you want, we can convert it to bzip too and transfer the compressed file over as well.
Minimum bandwidth. I'm not sure whether I'm at liberty to say all that, but we do have dedicated lines running from Bangalore to Los Angeles and San Francisco.
So computation is cheap, but like the bandwidths are expensive, right? So if you're saying 100 GB of data you are doing, the transfer, upload and download each day or every year, whatever, right? It's very expensive. So using like LG 470, you can do it like much better, like even better than the previous, right? So this could be.
Sure. Yeah. Oh, but then at that point we're spending more time compressing the file.
Computation is cheaper compared to the bandwidth. Right?
That is true. That is true. But unfortunately, we haven't run into that kind of a situation.
So yeah, I mean the solution that I'm not at liberty to say some of these things, but think of it as there was an existing paradigm in which we're trying to solve the problem, and at that point bandwidth was cheaper for us than asking for more machines.
Okay, so I guess we would.
Yeah, there are no other questions. Oh yeah, there is one. If there's time.
Okay, so I've got space time with a question. His Twitter handle is space time. 29.
You mentioned you were working on a module for the load balancer, which you're developing. Is there some reason that you're doing it in-house and not releasing it to the community?
I expected that question, yes. So we are in talks to get that open source. As a matter of fact, DreamWorks does contribute back to community. We open source something called as OpenVDB a while back. We had to talk about that in SIGGRAPH. So we are committed to the community. We do open source. We are in talks to get that open source. There's no reason why it has to be inside.
And we've recently started committing to something called Res. That's on the GitHub page for DreamWorks as well, so you could check that out as well.
Yeah.
Okay, so I think we should just end it up here.
Thank you very much.
So just give them a huge round. So thank you, Jeffrey. Thank you, Utkarsh. So we got a 30-minute break. Okay, so you guys can just freshen up a bit and be here in the